Boom.
Radio button.
Present a screen. Good night, everybody. It's welcome to Robot Builders Night Virtual for July 9th, 2024. As usual, we'll do our round robin, roundtable. Everybody can spend a little bit of time discussing what they're working on, any progress they've made. Later on, we can have some ad hoc presentations. If you have any questions, you can try to stump the club and ask whatever you need. Maybe somebody can help you out. And just to let you know that we do record these meetings, and by joining, you're agreeing to having your picture and audio presented. Otherwise, we encourage you to keep your camera off and your microphone muted. Thanks. And we have a list up. I had a list somewhere. I'll put that in the chat.
Paul, you still out in the Wild West?
Oh, there he is.
Okay. John, if you're ready, we'll
I'm ready. Okay, so you guys should pin my video here, and I'm going to share something at the same time, so it'll show up as well, hopefully you'll see these things both like reasonably big. Can you guys see that?
Yes.
Okay, so, and as you know, one of the robots I've been working on is my balancing robot, and you can see it runs, but I still haven't gotten it to balance. I think there's something fundamentally wrong with it, but you can see it displays the PID values on the screen here. And so right now, P is 0.090. So as you know, I wrote something for my, here, I'm just going to put that down so it stops spinning. I wrote something for this to allow me to adjust it, but it turns out that's nice for doing one-off things, but it's really awkward when you're trying to change constantly over and over and over again. So my next step in that was, whoops, sorry, I'm just going to put this down. I'm going to plug this guy. I have this little, this is, I'm basically calling this an ESP32 dongle. So it's a tiny Pico, which is an ESP32, and a screen, and there's a push button on it. And so when I plug it in to my computer, the screen comes up and it says URC dongle ready. And so it's now connected to my desktop here. And so I have this command called send, which I can, and if you watch the P value on here, you see it went PID update when I hit that, and now it's 0.075. And if I change that, I can change /D to, what's D right now? 0.115, so I can make it 0.085, let's say. And so if you watch it again, it updates both of them. And so I can change them that way using a command line interface. So that was kind of cool. And this is using ESP now. So the basic idea is I've got a little Python script that I run on the desktop here. And it basically just connects to the serial port, and it uses argparse to parse out the P, the I, and the D value, and then it creates a serial port to /dev ttyacm0, and it writes the packet. It creates a packet basically, which is a dictionary in Python, and then it JSON. It turns it into JSON. Packet string is packet string. Well, it's yeah, so packet string is JSON dump S. So this line here, it converts it into a string, and then it adds converts it to UTF-8, which basically makes it a byte array, and adds a line feed at the end, and then I write it to the packet string, I close, and then I'm done. And so then on this board, I'm basically listening on standard in on the MicroPython board, and when I get a JSON packet followed by a line feed, I parse that, and then, well, I basically forward that packet to the robot over ESP Now. And so that allows me to, and then in the robot, in addition to doing what it's doing, it's got a listener on ESP Now to listen for packets. And one of the things that it listens for is adjusting the PID values. And so I can adjust the PID values in real time while it's running. So that's kind of cool, wirelessly. So that was nice, but it was still kind of a little bit awkward. So I'm going to unplug that. So then I built this in the last few days. This is actually an ESP32, a Tiny S3. So it's similar to the Tiny Pico. I started out with a Tiny Pico, but it turns out, and this is kind of a little bit of lore for this is the paper for the Tiny Pico. Actually, I'm going to stop sharing my screen here because you don't need to see that part anymore. So this is the paper for the Tiny Pico, and there's something interesting with the Tiny Pico. Well, ESP32s in general, they have two A to D channels, channel 1 and channel 2, and it turns out that the Wi-Fi system, when you've got Wi-Fi enabled and turned on, the Wi-Fi system uses channel 2. But the Tiny Pico, almost all of the A to Ds available on GPIO pins are on channel 2. So I was sitting here with the Tiny Pico plugged into this, trying to figure out why it wouldn't work, because every time I turn Wi-Fi on, it's the A to D stop working. And then I did some research, and it's like, oh, they have to be channel 1. So then he went, and I also have some Tiny S3s, and he changed it so that all of the GPIOs that are A to Ds on the Tiny S3 are on channel 1. So you can use all of them with Wi-Fi, which is nice. So anyway, I switched to using that. So this has got the same screen. It's got 3 pots and a little push button. And so this guy, I'm just going to plug it into a USB battery bank. And it comes up and it shows some values here. And the cool thing with this is real time. So let me arrange this on my desk here, because I got to hold this guy up to the camera. I'm just going to change the P value for now, but you can see I'm turning this dial and I'm changing the P value as I go. And so that's just changing it in memory. Anytime that I want it to, I can push this button, and now it will save it to that JSON file on the drive. And so now if I power off and power back on, it will come back up with these values, which is kind of cool. And then I can change the D value as well with this, which you can see is there. So I'm turning it while it's 0, and you can see it's going up. So that's kind of neat. And like I said, anytime I want, I can just push the button and it saves it to the drive. So that's kind of what I've been working on lately. And then a couple days ago, my
That's a
PC.
great tool.
Yeah. It was frustratingly fun to write.
Hey, John?
Yeah.
So do you have some kind of absolute value you read off the pots and you have to look at the numbers before you send them? Or when you initialize it, does it take as 0 whatever the pots happen to be at, so that then you can do deltas?
Oh no, it's absolute.
Okay.
Yeah, I take the A to D value and convert it and then go from there. So convert it to the right scale. And so this guy, which I showed you guys the definition for last week, this is really amazing. So I ordered this from JLC PCB, and I ordered this on, I sent the order in on July 4th, and it showed up to my house on July 8th, which is friggin' amazing for a $30 US dollar board. So anyway, so that's the board from my Robo Magellan or Robo Columbus robot, and I've got it sort of installed there and starting to add lots of wires and stuff, which is always tricky. But it's starting to get there. I'm still, I had to do another DigiKey order because I'm missing 2 switches and a couple 2-pin connectors for power. So anyhow, that's what I've been working on this week.
I have a question about your the code that you use on your desktop. I noticed that you open the serial port and then close it every time. Is that just
Yeah, because it's a distinct command that I run, right? I run the Python script and then it goes away. So it opens the port. Now this is the port to the Tiny Pico, right? So it's not the ESP Now. The Tiny Pico code basically creates an ESP Now connection and leaves it open, and it creates a serial port connection. I mean, the serial port connection is standard in, right? Because of the fact that I'm using the actual USB port on the board. So, and that's the reason why I added this button, because as you know, on these things, in order to program them, you need to be able to hook up to the serial port and actually be able to send a Control C. Well, I want to be able to send binary files through this interface, because eventually I'm planning on doing OTA files using this or something like this, so I can update MicroPython boards, you know, my ESP32 boards on any of my robots without having to plug into USB. But then I can't program the board. So if you push this button while you plug it in, then it drops into basically what I call bootloader mode, which means it doesn't disable Control C, and it just exits to the read evaluate print loop. And so then you can run R shell and connect to it and whatever. So it basically allows me to start it up in 1 of 2 different modes.
Hey John, what PID controller are you using? Did you write your own, or are you using a
So I've had a couple of them. So when I was originally using my BNO 085 IMU, I used a PID controller that somebody else wrote, which was an actual, like a PID class. I mean, PID's not complicated. It's just basically a 1-line equation. You know,
not when you want like different integration wind up prevention methods and feed forward control and you know, fully instrumenting it and stuff like that. So it's like I haven't found a satisfying PID PID library in Python yet. No.
I'd be surprised if you were happy with this one. It's let me see here. Let me share my window here.
I've been going through the same search for a PID loop in Python actually this week.
So this is the one that I'm using, and this was a simple PID controller. I have no idea who wrote this, but it has, you can pass in, you know, PID constants, set point, sample time, scale, output limits, auto mode, and a few other things like that, and it takes all of that stuff. So this is a fairly complex PID controller, and that's what I was using originally with the BNO.
That doesn't look terribly complex from the.
Well,
like we've written our own, and it's like they end up longer than that if you're.
If you
want
want
all the bells and whistles and stuff.
Yeah, I haven't been using any of the bells and whistles, but I'm not using this right now because I read that paper that I linked to last week about complementary filters, and in that one, that's
a different methodology.
It's a different methodology, exactly, and it's basically taking the p-value against how does it work? The p-value goes against the angle, and the d value goes against the rate gyro, and then you combine those together with a time constant and some math and stuff, and you end up with a value. And that one actually works reasonably well with the IMU that I'm using right now. But I still haven't been able to actually make the thing balance. I think there's something fundamentally wrong with this at kind of like a hardware level or something. I'm not sure.
Lag will certainly kill you.
Yeah, I
If
mean,
there's
I'm
any
running
lag in your
I'm running at 100 hertz. You know, and
that doesn't. Well, okay, yeah, that should be good. But
yeah,
but it really depends on whether your sensor feedback is.
Yeah, well,
there might be lags in there that you're not aware of, right?
Yeah,
sort of like the whole frame rate problem with.
Did you see the thing that I did last weekend? Or
yeah,
last week, the little graph thing that showed the, you know,
I may not have been looking at the screen then. Yeah.
Okay, well, I let me just find it here. It was kind of interesting because it's a I basically built a jig to allow me to oh, it's on my laptop.
John, just to clarify, are you running the PID loops on your self-balancing robot at 100 hertz?
Yeah, I'm running everything at 100 hertz.
Okay, that's really fast.
I don't know, it's not that fast. It's fast, but I mean, it's, you know, MicroPython doesn't have any trouble doing 100 hertz on an ESP32.
Yeah.
The faster, the better, as long as you're, well.
Yeah, you're right. If you've got,
it can be better.
Well, run it.
Yeah.
Yeah, I think 100 hertz is fine. And I built this jig that I put the two IMUs on. So, and it has a pot on the end here, and I hooked this up to one of my STM32s. So I'm basically reading both IMUs and the pot at the same time, and then I graphed the output. Actually, you know what? I probably still got that in my. Let me see if I can find it in Google Sheets.
That's a good test rig.
Yeah, and so, do I still have the graph? Yeah, I do. Okay, let me share my screen again. So this is the results. So the blue line is the pot. Okay, the red line is the BNO085, which I'm sampling. I'm running it in RVC mode, which means I hook a UART. It's hooked up via UART, and it basically sends me you don't have to like ping it at all. It just sends a packet at 100 hertz. And that packet includes pitch, roll, yaw, and the 3 accelerometer values. So you can see that, you know, other than the magnitude difference here, just because I didn't do the scaling right, it's almost exactly on with the potentiometer, which is of course directly connected to the thing. So there's no issues. And then the green line is the gyro, the raw gyro reading from the ICM 2980 or 948. So you can see, you know, of course, it leads it a little bit because it's an acceleration rate, not a, you know, this is a position and this is effectively a velocity. So but anyway, there's virtually no lag in the BNO085 when you're running in RVC mode anyway. So I thought that was a pretty decent test for that. So yeah, so I think there's something fundamentally wrong from a hardware perspective with this robot. So I'm putting it aside for now because I finally got my PCB for this guy for the outdoor rover. So I'm going to basically start focusing on this because I want this to be ready to rock and roll when we run the competition this fall.
Thank you very much, John.
John, I agree with that philosophy. You need to clear the decks because it's always going to take longer than you think it's going to.
Yep.
Okay, up next, I guess, Mike.
Okay. Well, yes, last week I was talking about my the soccer ball, and so I'm going to talk about that, and also going to just get up to date on my Robo Columbus robot. I got some stuff done on it, but so you might tend to get big. So this is the Sphero Bolt, which is a ball like a sphere robot, and it runs really nice. It's really well designed, and I got it used for $50, but that's about as cheap. I saw some cheaper ones, but this one felt comfortable to buy from. So, and it's you can drive it or you can program it. So I've been programming it also, and so this is the gear that I got that goes together, and so I'll put the robot inside of here and show it off, and it actually moves, which is good. So let me point my camera to the ground. Okay, and I'm going to set the robot down, and the first thing to do is to orientate it so you know which direction it's going. So on the app here, you know, that's a program I have, but I can aim and I can drive with it. So let's see. Oh, so I don't know if you can see that, but it's pointing in the right direction. So that's good. And then I can so I'm going to put this back together. The idea of this project was I didn't want to build anything because it's just a prop for a show, and so I'm going to use the drive function on it. So I'm going to make it go forward. And then go sideways.
That's awesome.
So
Indeed.
it can do what the production manager wanted it to do. So that's good.
Would it be able to climb a carpet? You probably wouldn't have one on a stage.
Well, yeah, there's no carpets where we'll be at, but it has to mingle with the audience, sort of.
It has to go into the seating area.
Well, there's no seating. It's all.
It's like an open.
It's immersive, so people are just standing with the actors and the musicians and the robots.
Cool.
And yeah, so that's so that project is.
All you got to do is paint the styrofoam.
Yeah, I'll let the artist
make it look like a soccer ball.
I'll let the artist people paint and make it look exactly what they want. And they'll just sort of wave their hands and say, I want to move it like this, and I'll make a program. Then they'll go, oh, that's not what we want. We're going to change it. So that'll happen. That'll just happen forever until
you might want to make sure that they test the paint on a piece of styrofoam that's not your ball, unless you can get more of them easily.
Yeah. So so basically, I'll need more. In fact, I'm going to say we need 2 balls minimum, because I know someone's going to kick it and break it. So I need a backup ball. And then if one breaks, then I'll actually create a new one.
Okay, wait a minute, Mike. So explain to me, this is for a production you're doing, is for like community theater or something along those lines?
Something like that.
Okay, you need 5 balls. I am not lying. I am not lying. How long is the production run for?
8 shows.
You might make it through with all 5 balls, because the people that are doing this do not care about your styrofoam ball. They care.
Somebody's gonna kick it. It looks like a soccer ball. Somebody's gonna kick it.
Somebody's gonna mess it up. You need at least 4 balls, 5 on the safe side.
Yeah.
I'm not lying. I'm not lying about that.
Yeah, because
somebody's going to flatten it, you know, fall on it.
Yeah, the lead up to this, the right before this ball comes out, there's a real soccer ball, and people in the audience is going to be encouraged to kick it around.
Oh,
Recipe for disaster.
And then an actor is going to take control of it and kick it off into the darkness, and then there's going to be a nuclear explosion, and a soccer ball that's all tattered and I don't know, just messy, is going to roll back out, and it'll be an AI automatic artificial intelligent robot. It'll just start moving around by itself. So,
Mike, what's the name of this immersive? Is it going to be open to the public, or is it like all sold out?
oh, we haven't. We're still designing it, but it's going to be in January, and it's in Fair Park.
All right.
In downtown Dallas. Yeah. So that's one thing, and then I'm also working on my Robo Magellan or Robo Columbus. Let me share something. Make sure I know what to share here. I want to share this one. Okay. So, okay. Where's my, oh, there it is. Okay, so this is, I've created a, oh, this isn't the right one. So I've created a GitHub's gonna have a README file in it. So I'm going to open that up, and it basically, I'm going to target the 2025 fall as when this robot's really going to work well. I might have something to roll around this fall, but I got so much stuff to do for the show. And so this is my README file. And so I was going to show a couple pictures in it. Like this is the picture of, this is box here is what I've been working on. And what that is, it's a MUX, the switch between the computer, which would be coming in on a USB, and the receiver, which is buried over here, and switching between those two to the motor and the servos. And so I got 6 servo wires going into here, 3 from the receiver and 3 to the rest to the car. And so my objective right here was to make it still work properly with the remote control. And then with the remote control, I go through a certain sequence and it switches over to the computer. And then the remote control acts like a fail-safe switch. So I gotta keep the trigger pulled. If I release the trigger, then it's supposed to stop. It'll stop. So that's my objective for that. And so the electronics board, I sort of made a close-up shot of it. Yeah, I'm more of just a wire solder guy. So I just take all the modules and put them into a perf board and wire it up on the back. And so this here is the MUX that Doug recommended a couple weeks ago, and it's a great thing. I'm glad you told me about it. I was going to try to do it in software, but this is so great because it works fine without this controller being powered up by the computer or anything. And then this is a WaveShare RP2040, which is my go-to, and it monitors the signals from the receiver and uses it to decode, if it's in what MUX mode it's in, whether it's muxing in the computer or muxing in the receiver. And it also would look at the trigger signal for the failsafe. And then this little board here is the level shifter, because this works at 6 volts, the receiver does, and this takes 3.3 volt signals. So, and then I got 2 power regulators to power the electronics, which will be up in the cabin of the car. Basically, one's for the Pi and the other one's for everything else. So if you look at this, then you can see that I got 2 power connectors coming out of it. And then it hooks in here to the battery, and I put a fuse on it. So it's all fused and everything. And I made a crappy schematic. I didn't bring up a schematic tool. So basically you got the MUX, remote control MUX, and you have the level shifter, and then the RP2040, and the USB cable, and then the 2 regulators. And I enable the regulators only when the car is turned on by using its on button, which enables the 6 volts to the receiver. So just plugging into the battery, these regulators don't turn on. So it has to wait till the car is turned on. So that's where I'm at right now. That's what I want to do. I wanted to break the line, put a MUX in there, and make sure it still works with manual mode, and also tested to make sure that the computer can control it. And right now I'm coming up with the JSON messages to steer and to do the steering and doing the speed and stuff like that. So I'm starting to work on this guy here, just to get it up and running so it can be plugged into a Raspberry Pi and then put some ROS on top of it.
Are you using the PIO things for the PWM inputs?
I have I use a library that does it. I'm doing it in Arduino C.
Oh, okay.
And it has really good PIO, a couple of good PIO libraries. So,
cool.
So I'm using 5 of them. I've got one for the steering. I don't know if you can read these little letters. The steering, the motor, and the speed. And then I got since there's a 4-channel MUX and it's a 4-channel receiver, but it's only using 3. But I just wired up the 4th one anyway. And then there's another one for the MUX select, and it's in PWM format. Right.
But those are PWM outputs. I mean, the RP2040 does that natively.
Yeah.
You don't need PIOs to do that.
And I just use interrupts to measure the pulse width of the inputs. I couldn't find a library to measure pulse width inputs, but it's just an interrupt is real easy.
Yeah.
A change interrupt. It's like, when it goes high, you capture the time, and then when it goes low, you measure the difference. And
yeah. My brother wrote a little utility in MicroPython that does the same thing using interrupts. So
yeah, it's about 5 lines of code or something like that. Yeah.
Yep.
Yeah. So it's working out really good. At least I'm moving forward and haven't blown up my nice car. And I can still drive it around, and it's still waterproof because this box here I made is all waterproof, and the wire connections are real tight, the holes. So it's not, I wouldn't say waterproof, but it's splash proof, which is all you need under the in the engine compartment.
Yeah.
Hey, Mike, what MUX are you using?
It's the Palulu.
Oh, okay. Yeah, I've seen theirs before.
Yeah, so I got them here. It's the 4-channel servo multiplexer. Yeah.
Okay.
Oh, I'll put this. Well, when I get back to the main thing, I'll put this into the chat, which is my GitHub. So I'm trying to document it as I go, which is nice. I sort of took a cue from John and said, okay, I'm gonna just make a really nice README file, and it'll keep me up to date, and, and I can look back in a year and a half from now and figure out what I did.
Yeah, I think that's the best reason to document it, so you know what you did.
Right. Yeah.
Yep.
So this is going to be a really fun car. I can't wait to add some automation into it. But
yeah, they're insanely capable.
It's really fun to drive too, just manually.
Yep.
In fact, I want to keep it so I can actually go crawling with it, because I've been watching the videos and they're so cool. So it's like, I want to do that. So I'm trying to keep it water resistant down here so I can do it.
Yeah, I'm just making mine so I can convert it back, because mine's is not going to be anywhere near water resistant. So I mean, but I decided to go with the software mux rather than a hardware mux. So I'm just doing that on my STM32.
Right. I was going to do it on the 0, but I was going, this hardware mux is so nice.
Yeah.
and nothing needs to be plugged in or powered up.
Yeah, well, that's certainly handy.
Yeah, because the servo power from the receiver, or I guess it's actually from the motor ESC board, powers the hardware mux.
Yeah, I decided not to use that power at all.
I'm not using it for anything except for that switch.
Yeah. Okay. Smart.
Yeah. So I'm taking everything from the battery and then putting into those 2 nice regulators, and then the cabin electronics will plug into these 2, one for the Pi and one for everything else, and then the control signals go into the USB.
Yeah, that's plugged into the 0, right?
Right.
Yeah.
Yeah. So just climbing, or for just rock climbing, I can just take these up so that they don't get damaged, and do whatever I want with the chassis.
Yeah, my conversion's a little more in depth, but I was originally going to keep the body, but I decided that I wanted the 0 approach angle, and that was really the sort of the killer for the body, because the body sticks forward of the wheels, and I don't want anything forward of the wheels, so I can run up a curb.
This one runs up curbs pretty good.
Yeah, well, that one's a lot bigger than this one.
Yeah.
I've only got 4.8-inch wheels, so.
Yeah. So I'm gonna stop presenting. That's basically my what I did.
Well, thanks, Mike.
It's very cool.
Yeah, a really neat update. Next up, we have Ray.
Yes.
Ray said he could do a presentation.
I need to ask all the 3D printer experts out there. Have you been able to find replacement parts, or a place where you could get replacement parts? Especially Doug, I know it's for an older Malon 150. It only came with 1 nozzle, and I spent like 2 hours yesterday trying to clean the thing out because it just would not extrude. Finally got it working again. But the nozzle looks kind of beat up, and they're different, or it's a different shape than like the Crealities and some of the other ones. It doesn't have the same shape to it, I guess. So I wondered if you found a source for those nozzles, maybe.
I do know that once the nozzle starts to go bad, the best thing to do is just replace it, because you'll be forever trying to keep it going and cleaning it, and it's just not worth it. But yeah, I don't know unless, do you know, what does the nozzle look like?
It's, brass in color. It comes to like a point. There's, and it's the point doesn't have any undulations in it. Some of the,
the size of the thing, is it a 0.4 millimeter type thing? And what's the thread on it?
I think it's, I want to say the nozzle hole is 0.5 millimeter, because I use one of those little PCB bits to clean it out. Actually drill it out.
Because I would say go to the company, or else be Micro Center has some nozzles, but I don't know. The key is that will it thread into the thing. When you take the nozzle out, it catches replacement threads, and they may or may not be the same. I guess and they are, but
yeah, I wondered if that was the case or not.
Micro Center, I would say, has some, but the key is they carry certain brands.
Yeah, you could just measure the thread size, and how far it is in down, it's threaded down, and that sort of thing. And
so that's kind of it. Once the nozzles, it didn't, well, I don't know, it just looked like an accumulation of, I don't know, like burnt plastic or whatever. And had various drill bits that I could use to, trying to clean the surfaces out and stuff.
Well, they come in
try a blowtorch.
What?
I burn them out when they're really bad.
Oh, you do?
Yeah.
Okay.
As long as you don't get it to the brass melting point, you're going to be.
Well, or else you can use isotope alcohol, basically melt the plastic.
Not all plastic
that's
is soluble.
Yeah. Mainly it's PLA, I guess. Isopropyl would dissolve it, maybe.
Yeah.
Okay, I'll have to try that. Yeah, Doug, I don't know if you ever tried to get replacement nozzles for your Malon 150. I don't even know if you still have it. Do you?
Yes, and I'm going to say that can you hear me?
Yeah.
The nozzles are very cheap and very easy to get. That is if you look at it, oh God, what do they call it? I think it's called a Mark III extruder. And, and you can get the barrels for that and the nozzles very, very easily.
Where do you go to get them?
You can get them on Amazon for.
So it is a standard size nozzle.
Yeah. Yeah, it's a standard. I mean, it was used on, I'm trying to think of what's that machine that was one of the early ones, but
was it a Persa?
No, not a Persa. There was another one that you remember, originally it was wood, and then
MakerBot?
MakerBot, yeah. I believe the extruder design is one of theirs.
Okay.
And so it's a very common extruder for a certain age of machine. Do you know what I mean?
Yeah.
You don't see them. You see more of the creativity, the reality ones now. But the other one, yeah, they look like that.
Yeah, you can get those on Amazon for like a dozen for a few dollars.
Yeah.
Okay. So is that one? It's just like a straight, comes to a point. It doesn't have like undulations.
I can get the focus there.
Okay.
It doesn't really matter what it is on the outside.
Yeah, the point
on it. It's where it meets the bed and the how it mates to the threads.
Okay. Yeah.
There's also two different there's like an MK8 and MK10 threads on those things. So there's a couple of different thread varieties that are on that that are very, very common. You just need to check them out.
All right.
Yeah, this one's the MK8, but yeah, if you just measure the threads, that's the key to.
Yeah.
Okay.
MK8 is probably the most popular that I remember for this style of printer. Now they've like Doug was mentioning, now they've gone on and now they're doing all kinds of stuff. Like this A1 I have over here, if I've got to buy their hot ends, but literally it's a 30-second or 45-second hot end change. The way they come and stuff now. Yeah. But you have to buy their stuff. You're not just going to go willy-nilly like Ted was just showing there to go buy some parts and then go screw them on. You know.
Yeah.
Is that a slice hit hot end? Is that a slice hot end barrel?
I'm not sure what the Bamboo folks use on their hot ends. Okay. But if you go on the Bamboo site and go look up accessories, you'll see what it looks like on the hot ends. It has a little bit of a, it literally is a snap fit in on the thing as it works. You're using a combo. They have a Bowden tube, but they've got 4 of them. They're also got a direct drive extruder inside their head because they measure flow before and after the internal extruder on the head itself as it moves around, so they can detect jams and do a bunch of other stuff that I never got around to making mine the one I built myself do.
Yeah, Ray, and another thing too is if you decide to go to make a lot of ABS, then I think it's called Micro Swift or Swiss Micro Swiss. They have an all metal extruder that is a direct replacement.
They have a well-known name, those Micro Swiss people.
Yeah, it's a little. It might seem at first a little pricey, but you'll have no problems. I mean, it's, you know.
And the hardened steel nozzles are, if you're doing anything with carbon fiber infused, you'll want something like that, and they're pretty cheap too now.
I
Yeah,
don't know if I'll ever print in carbon fiber. That's a.
I've even seen similar nozzles with ruby tipped and some ceramic insert or something. I mean, people are making some crazy stuff out there now.
Yeah, it is kind of funny with those things about all the different nozzles and stuff. But also, there's a video. What my impression was, the carbon fiber wearing down the nozzles will like wear out the inside of it, and there might be some of that. But I saw a guy did some experiments where he would wear one down and then shave it in half so you could look at the cross section. And really, what was happening was you come down to a tip like this, and because you're running over the top of that other plastic so close, depending on what you're doing and going back and forth, you actually rub the tip of that off. So this tip that looks like this now becomes like this, and it gets open more because the hole in the middle is open more, and the really good milled nozzles have a straight bore to them. They're really nice. Most of the ones you get from China, they're going to have some wobble to them, and as it wears down that tip from the outside, that wobble becomes pronounced, and you no longer have a round hole. You're squirting stuff out. It was a really.
It also increases the diameter size if it's not hardened, though.
Yeah.
Right, because as
the tip wears down, because it does like this, the wear down part does this number, right? So it will make it bigger. And if you don't have a nice bore into that thing, you get a non-round hole out of that thing. So
yeah, I would not be cleaning them with a drill bit.
No.
Oh no.
It needs to be a certain size. That's why I was saying.
I'll tell you what I take a brass brush, like you use whatever you use brass brushes for, and you take one brush piece and just bend it 90 degrees. So now you got the brush handle as a nice handle, and you just go up and down inside of the nozzle, and you won't damage it, and that works really well. But
I use a acetylene torch clean outs.
Yeah, but you see, I don't even take I at least try this brush technique, and then 8 out of 10 times I don't even have to take the nozzle off.
I've melted nozzles with the acetylene torch technique before.
Yeah, and
No, no, no. Sorry. I was talking about two different things. One is the, I wouldn't use acetylene to burn out.
No,
No,
Pretty
that's
hot.
way too hot. I'm just talking about a regular,
Propane or MAP or
propane
something.
torch. Yeah. But no, I was talking about the clean out reamers for cleaning out acetylene nozzles.
You're talking about the tip cleaners.
Huh?
The tip
They're like
cleaners.
yeah, the tip
Acetylene
cleaners.
torch.
Yeah.
Torch tip cleaner. Yeah. Oh, okay. Yeah.
Torch tip cleaners. Yeah.
Yeah.
Yeah. But like
Yeah,
I
the
say,
little drill bit worked really well.
the thing is,
but they are so cheap now. It's just replace the damn thing.
Yeah.
Okay. I would bet you, Ray, if you rolled down to Micro Center right now, you could buy a bag of those for less than $10.
Yeah, I saw them on Micro Center. I was a little concerned. The shape looked different, and I don't know if it's the right length or.
The key is the thread and the size of the nozzle.
The threading, right?
Hole out the nozzle. That's what you. Yeah, the hole that's coming out and the size of the thread. Everything else.
Yeah.
Aesthetics.
Okay, when you said MK,
it also has to mate cleanly to the inner surface of the hot end. Because that's where you'll get ooze if you're like the threads themselves don't stop that. Huh?
They're all going to be the thread length on almost every one of these things we're talking about are all going to be about the same size, so it should match up unless something. Really
I've been burned by that before.
Well,
they generally are, but you can get variations. So
what I'm trying to say is, Ray, you shouldn't have any trouble getting them replaced.
So that's where it comes down to you tighten the nozzle to the heat break, not to the heat block.
Yep.
So, and doing that, or you got a couple techniques to make sure you're doing that. And that seepage happens all the time if that doesn't happen.
Yeah. Well, this one was pretty good. There was no seepage, but it was just so jammed it wouldn't, nothing was coming out. So the MK8 and the MK10, is that just a metric?
I'm not sure. I'm not sure how they did that with the thread size, but they are different and one don't fit the other.
Okay. Yeah.
Well, you can again go to the Micro Swift, look up the replacement one and see what they say fits theirs, because it'll work.
Okay. Did you say Swift or Swiss?
Swiss.
Micro Swiss is a
Hey, can you hold that?
I have
Can't read it.
Oh, you're out of focus.
Yeah, bring it up close.
Put it in front of your face. Put it in front of your face, but next to the camera, because it focuses on your face.
Okay, there you go.
You got to hide your face.
Thank you, Ted.
It still won't focus.
Oh, that's close enough. I got the general shape there.
Stop talking about Ted's face that way.
I broke my camera.
Okay. Anyway, so after I got the 3D printer printed, I printed some parts again. It's great. One of the things that I was experimenting with, or has been wanting to experiment with, is different kinds of beacons. And I've had this, it's a 940 nanometer laser, which that's in the infrared range. And I have these infrared receivers also for 940. And I wanted to mount them on the inside of a basically kind of like a shield. So this is divided up into 18 parts. So it's 20 degrees per increment. And then the receiver was going to sit back here. So when the line laser shines across these, only one or two should, receive the light directly. All the other ones should be blocked by the angle of the fins. And so I've got, there's an analog multiplexer that's been out. It's like a HC, I think a 4067, which is a 16:1 mux. And basically, I've got 18 inputs to multiplex in. And so I'm gonna try to use two of them. and just see how well it works. And it's been a pretty cheap experiment. I think 40 of these was, a couple bucks, and just the little bit of plastic that it took to print that. So, but kind of wanted to experiment with it for a while, and finally got to do it. So
I suspect you're still going to get readings on the neighboring cells, because the specular reflections work very, very well on getting in, because you're going to have a high angle of attack on incoming rays on the neighboring ones.
Yeah.
In that design, and unless you're using something, this would be a place where a carbon fiber infused plastic would have been helpful for a totally different reason, and is that they tend to print really rough.
Oh yeah,
the edges, right? And so it would have far less specular reflection than, say, like a shiny plastic PLA.
You could paint it with flat black or something.
Yep,
that's true. Yeah, I could try that. Black
it should still
velvet
be less.
flocking, maybe.
There you go. Flocking, yeah.
Anyway, so I wanted to try it and see, and yeah, I may get up to 3, but it's doesn't have to be down to the fraction of an angle accurate. It just has to
So
say.
is that going to be on the robot or on the?
Yeah, this is going to be on the robot.
So how are you going to steer which one is the beacon? So then the laser is the beacon?
Yeah, and that's going to be mounted on the can sucker and the 2 of the corners.
So is it a horizontal line laser or something?
Yeah, I have there's a Fresnel lens. I don't know if you can see it on the end of that, but
yep. So you can make that spread horizontally?
Yes.
At the right height? Okay.
Yeah.
Interesting.
Anyway, don't know how well it's going to work, but I've been wanting to try it for a long time, and finally just said, okay.
Let us know. That sounds cool.
Yeah. Other than that, yeah, that's all I got. That's worth mentioning anyway.
Well, thanks, Ray.
Ray, just one thought is, you could for your nozzles, you could go to Amazon and get samples of both of the threads and just return the one that doesn't work.
Okay.
Because I don't like Harold said, I think it's like 10 or something for $4 or something. It's usually not real expensive.
Yeah. Yep. So is your Malon still a serviceable printer?
Yes, I use them all the time.
Oh, you do? Yeah, oh, you've got more than one. Huh?
Yeah, I've got 2. I got one set up in a enclosure, and I use high temperature filaments in that one. And the other one is just a PLA, and it just cranks out. That's the one I use probably 85% of the time.
Yeah.
Yeah, and it just cranks out parts.
Yeah. Yeah, at the time, I think they were on sale at, was it Hobby King?
Yeah, I think so.
$150, and I think a lot of the other printers
at that time
much higher than that at the time.
Yeah, they were like 300 or something. I mean, it was like, wow,
Yeah.
Yep.
Yeah, all metal frame.
I think I got the second one for even cheaper because it was an open box or something. Yeah. So.
Yep.
Crap I put on, the post, the things I did to it afterwards. It was fun because everybody loves to take something and make it better.
Mm-hmm.
And it was probably a lot more. The upgrades were probably, most of them were 3D printed, but there were a few that cost a little money.
Mm-hmm.
And they have run. I haven't had any issues with them. I screwed up a board on one of them, but that was me. I later found out that I made a mistake, and there was a wire in one of the connectors that was loose, and I thought it was the board. By the time I got the board all screwed up, to try to troubleshoot it, luckily I was still able to get a new board at that time.
Yep. Yeah. Yeah. I don't know how old they are. Probably like 6 or 7 years now.
I'd say they're probably more like 10.
10 years
So,
old? Oh, really?
Yeah, they're pretty old.
Huh. Okay. Anyway, solid little printer.
Yeah.
Well, thanks, Ray. Next up, I think Tom had a question.
Okay. I'm going to share a little example here for a moment so I can find it. Okay. As I look at how to move the stuff I'm very comfortable with doing in C for Arduinos, I'm very interested in what it takes to produce the equivalent of a data structure in C, which I have several of in this robot code, in order to be comfortable and satisfied with the way I'm building structures in Python. And I admit I am heavily biased by all my experience with C and with tiny computers like Arduinos, where you worry a lot about constraints on memory and constraints on CPU cycles. And I probably worry overly much about them. So I've spent a fair bit of time trying to understand all the various data structures available in Python and some of the implications of using them, from an efficiency, a mutability, an indexing, a heap issue, a garbage collection issue. How do I understand how to apply these things, recognizing that I'm probably over worrying the issue, but it still seems like no matter how you build robots, you will eventually use all the performance you've got and want some more. So it seems like it's wise to have some reasonable grasp over how efficient an implementation of, for example, a data structure is. Hence my question, and this particular example, some of you may recognize this example as a version of Anderson's subsumption output data structure. In the code he's published, he wrote it as a structure. I modified it slightly. This has to be mutable, of course. And in this case, it's implemented as integers. Let's see, a byte, an integer, and a Boolean. It doesn't have to be that way, but this happens to be a useful example for what would be a practical alternative implementation. I've been browsing through how to do tuples, name tuples, dictionaries, classes, lists, sets, arrays, byte arrays, you name it. They're all over the place. So the question is, what are other people doing? What are your thoughts on this whole matter? Acknowledging that I'm probably overdoing my concern about efficiency, but nonetheless, what do other people do? John, you made a suggestion earlier about a class.
Well, it depends on what you're trying to do, like what you're trying to accomplish. Here, I mean, if you change the squiggly brackets to round brackets and get rid of that comment and uppercase the F on false, that'll, and get rid of the semicolon at the end, and just say T request equals, that would compile in Python directly. So you get an array of arrays, which is what this is in C, I assume, right?
Yeah, that's what I was thinking, actually.
So I mean, you can do that, but let me give you a 10-minute overview here if you're interested in.
I'm happy with that. Yeah.
All right, so I'm going to share my screen.
I'll close mine. So you guys are familiar. This is just a simple example, only several. I'm going to close my window if I can. Oh, yeah. It's already gone. Perfect.
Yeah, no, I can do that. So here's an example that I use in my URC code, running on the little round screen thing. So I use finite state machines a lot, and so in Python you create a class, and a class is really just two things. It's state and behavior. The state, you can think of it as like a struct effectively. So when you build an instance of a class, you know, a class is kind of like a template. When you build an instance of a class, it has instance variables. I think they call them member variables or something in C++. It has the same sort of thing. So basically, in this case, in my class state, I've got 4 variables that I've created here in the init code. and I pass them in as arguments when I build it. And so I say self.userEnter is this argument here, user update, user exit, and the name. And then I have a few other functions that are methods, they're called in Python, to do various things. So I also have this another variable that I've defined in this method. I mean, in strict Python, you should define all of your variables in the init function. You don't have to. So in this case, I've created a new one. Every time you call enter, I basically set start time millis to be the current millisecond clock counter value. And I check and see if the user has defined an enter callback, and if they have, then I call it. And so anyway, so the point is that you build a state object, and you also build a state machine, and a state machine has a bunch of state objects. Although it doesn't really keep track of them, what it keeps track of is just the current state. And the states keep track of how to transition between different states. So as an example of how I use this in the touch manager, so when I, this is kind of deep URC code, but the class touch manager has a state machine that it handles when you touch the screen. Because you get different events happening, and when you lift the screen, you want something different to happen depending on what state you're in. So I basically I've got 5 different states that I do, and these are all stored as instance variables in the touch manager, but I'm basically creating a state with a bunch of values. The first value is just a string, and the rest of them are actually functions. So enter wait for touch is actually, if you don't put the curly bracket, is basically the name of this function. So you can pass that as an argument. It's kind of like a lambda in some other languages, but it's effectively a function pointer or a callback. And so what I'm saying is, when I transition to the wait for touch state, and I actually start the state machine in that state, when you enter it, I want to call enter wait for touch. And when you handle it, I want to call handle, and I don't need an exit one, so I don't pass anything in. And the idea is, when you're in a state machine, the first time you enter a particular state, this function gets called just once, and it sets this local this instance variable in touch manager to be something, and then this is called repeatedly as long as you call update on the state machine, and you're in this state. And so if the touch type is touch down, so basically when we're waiting for touch, we just wait for a touchdown and do the stuff. But the point is that the state machine holds on to a state, and the code here effectively creates the graph of the states that form the state machine. So inside a state handler, if I meet the condition, then I ask the finite state machine to transition to this other state. And I actually pass the reference to my state that I created, that I initialized. And so I say transition to that state. And if you look at finite state machine, when you say transition to, I just say self next state is going to be that. So the next time you call update, if the current state is not equal to the next state, then we're transitioning. So we ask the current state to exit, we set the current state to the next one, we enter, and then we ask the current state to update at the end. It's really simple stuff, but you can see how I've got all of these objects that contain behavior and they contain state. And it's a nice way of encapsulating those two things. So for your
I see where you're going here.
Yeah, for your subsumption architecture, we don't tend to make global structures in Python. because it's, you know, you can only have one of them. You know, if you can create a single instance of a class. So for instance, in main, in the finite state machine, or in the URC, I have a class called failsafe. And so I build it, and it builds displays, and it builds windows, and a whole pile of things. And
all right,
so this is the definition of that class. It's only a few lines of code.
I see where you're going. For example, my submission, my subsumption build was actually to separate out the code from the data structure. What you're saying is build it as a class and combine them.
Yeah.
Yeah. Okay. Gotcha.
Yeah, exactly. And then the main code just basically builds an instance of failsafe, and that's all it does, because this is all interrupt based. So I don't actually have a main loop. My main loop just sleeps.
Yeah.
That's all it does.
Okay. So within this example that you're showing us, you've combined methods and attributes. And what structure are you using for the data here? It looks like it's a fairly straightforward set of individual variables. Do I understand that?
Yeah. Yeah. I mean, you can think of it like a struct,
right,
where you can dynamically add parts to it, and you don't need to type them.
Okay.
So I said self display is equal to create a new display object. And so I didn't say what display was, what kind it is, or whatever. It doesn't matter. It doesn't care. They're all pointers, right? It's a 4-byte pointer.
Mm-hmm.
So it doesn't care what type it is. Everything in Python is a pointer.
Mm-hmm.
And you know, so you create an object, which is an instance of this class, and you assign this named pointer, which is held inside this class. So when you build an instance of a failsafe and it runs the init code, well, it creates a display variable, it creates a window manager variable, it creates a whole stack of other variables that are all instances of these classes, these various classes.
Mm-hmm.
And sometimes I can ask the window manager to push a window chain. And so that's an object that I created up here as a window manager. And if you go and look inside the window code, the window manager class has an instance, has a method called push window chain. You know, it's very straightforward stuff.
Okay. All right. John, that's certainly food for thought, because that's a completely different way of thinking about how I should design these objects I want.
Yeah.
I just wondered, does anybody else have any thoughts on the movement from C to Python in terms of data and data structures?
I'm just going to make one more comment here, because you asked about garbage collection and stuff.
I don't want to go there.
The reality is, most of the objects that you're going to create don't go, the big objects that you're going to create don't go away. You know, you create references to them and you build up these graphs of objects, and they don't go away. So they will never get garbage collected.
Okay.
So you don't have to be concerned about that. The neat thing about Python with the garbage collector is you can do things that you can't do easily in languages like C and C++, in that you can take an object that you have and you can extract, say you've got an array, you can extract a piece out of the middle of it and assign it to another variable, a temp variable, and that just goes away when the method returns.
I noticed that, yes. You're talking about slices or views?
Yeah, or things like that, and it just goes away and you don't have to worry about it. Now, I mean, if you're running a tight loop at you know, a kilohertz, and you're doing that all the time, then yeah, you're going to run into garbage problems. You know, but the answer to that is don't do that.
Yeah. Well, what I was wondering about was how to avoid doing it, and if I ended up having to do it for some reason, then do I have to explicitly schedule garbage collection as part of my cooperative scheduler?
No, you don't.
Okay.
I sometimes do. Do explicit garbage collects in particular places, but very, very rarely. Like in the URC code, I do no garbage collection whatsoever.
Okay.
So it's
All right. Anybody else have any thoughts on moving in the Python data direction? Okay. Well, since it came up earlier, I'll mention one more thing. I've also been looking at what PID libraries I want to use or modules. I'm going to start with Martin Lundberg's Simple PID, which appears to be quite popular, well supported. He built his design using the design that Brett Beauregard did. And I happen to have used Brett Beauregard's PID controllers several times in Arduinos, and I think they're very good. So I'll start with his and see what happens, or I will use the basic PID, which is in PyPy and is easily findable from Thonny. But I'm going to start with simple PID and see what happens.
You're not using Thonny, are you?
I am using Thonny.
Oh.
I like it. It's simple. I understand it. I learned it fast.
Yeah.
I'm getting too old to spend a month learning a new IDE, John.
Doesn't take anything to learn. It's just a text editor.
Well, okay.
Yeah.
Anyway, that's my choice.
If it's just a text editor, then why aren't you using it, John? Just saying.
Well, I don't use Thonny because I don't like the way Thonny talks to the MicroPython chips.
So you have an opinion. So you have an opinion and you like it, which is great. Right?
Yeah.
So everybody has their own opinion. So there you go.
Yeah.
Anyway, so that's my that'll be my PID choice when I move the speed regulators and position regulators over to my Raspberry Pi Pico.
Yeah, but Harold, you missed one thing. Everybody else is wrong.
Oh yeah, I forgot that part. I forgot. I let that. You know, I did say that, but it was under my breath and off camera. So.
Yeah. Yeah.
Except for Emacs. Emacs is always right.
Oh, be out for life.
Thanks.
Okay, that's all I had. Thanks.
Thanks, Tom. Next, I guess we got Mike again. He's got a question about Human Pose app for OAK-D Light camera.
Yeah, I mean, I was trying to find the Pose Human Pose app for the Light-D camera, and I found one, but I can't get it to run. I can get out a lot of the other examples to run, but that one just fails. I'll show the screen that the error it sends me. Let me see. Which one is it? Ha! I don't know which one it is.
Are you using the Depth AI experiments or just the stuff in Depth AI?
Oh, I guess I can just, let me see. The Depth AI demo that it comes with doesn't have a pose. So I'm looking at the experiments. So which one is that? Oh, yeah, it's the Luxonis Depth AI experiments.
Yeah, there's something in there called the Gen 2 Human Pose.
Right. And when I compile it, when I try to install the requirements, it says that I can't, it says error, failed building wheel for NumPy. And I haven't figured out how to get around that.
Hey, Holly, could I trouble you for a napkin?
Okay. We're going to mute Paul. Okay. Just for now.
Yes. So basically it says error, failed building wheel for NumPy. And I've been trying to figure out, well, how do I fix that? And I wonder if anyone else had that problem when they tried to pip install the requirements. Let me see if I can bring this up. See, I'm going to try it. Uh-oh. Oh, here it is. Okay, so let me do the entire screen. Oh, I can't do the entire screen. Is it this one? Let's try it. I messed up my screen sharing, so I can't share screens again. It'll work again next week. So, oh well. So I was just wondering because that's the one I tried to run, and something's wrong with NumPy.
Yeah, that's kind of weird because I mean NumPy is one of the big, main things that everybody uses for all kinds of stuff.
It seems to work, but the wheel thing's not working. I don't even know what it is. But okay. Well, I'll just keep beating my head against it, see if I can overcome it somehow. I've been doing some Google searches and stuff, and just goes down little rabbit holes and doesn't really help me.
There's Luxonis has a Discord server. Now, they don't hang out in it, but lots of people that use these things do.
Yeah,
so
I think I went to that, but I just needed to spend more time on it. Yeah, I spent hours, a couple of, 3-4 hours on it, and said, I'm gonna move on. Come back.
Yeah.
All right, that's all I had to say. It's like I'm trying to get that thing for Moon Day, and if not, I'll just put something else. They had some other cool ones, but I wanted to get that one to run. Okay, thanks.
Thanks, Mike. Next up, Paul had a short video on taking a ride in a Waymo self-driving car today.
Yeah. So, can you hear me? Am I coming through okay?
Oh yeah, we got you.
Great. So we had a fun day of trains, ship boats, and cars of all kinds today in San Francisco. We drove to Daly City and then caught the BART train into the city, and then caught a cable car up to the cable car museum and looked at the motors running these monster cables in and out that run the entire cable car system in San Francisco, and then caught a ride that was driving a Tesla down to the Alcatraz boat and went across the Alcatraz on the boat. But the highlight from the point of view of this group is when we finished the boat ride, we figured out how to order a Waymo taxi, self-driving taxi. And it was just a blast. It was a hoot. So I put together a video, and rather than try and present it here, what I suggest is if you click it and then get ready to start it, but don't start it playing. I'll narrate it and narrate it as it goes. Does that seem like a reasonable thing? I'll give you a countdown to
yes.
Okay, good. So I'll give you a countdown for
I got mine up.
Okay, I'll give you a countdown for when to press play, and then hopefully we'll synchronized and my comments will make sense in the context of the video. So
everybody else
is anyone not ready?
Yeah, everybody playing the video should mute themselves.
Oh, yeah. Good idea.
Okay, all right. Everyone ready to play? Okay, 3, 2, 1, play. Okay, so that's my wife Holly standing after the ride. So and just we were going about 30 miles an hour, and we're videoing like crazy, like looking around and experiencing the whole self-driving thing, which was a really neat experience. It felt like quite a cautious driver, but not tentative. Here you see a car parked halfway out in the lane, and it gently moves partway into the other lane and then back into its own lane. It never paused when that saw that vehicle turning in front of it. Just carried smoothly on and nothing had happened. And then came up behind this car that is stopped at a stop sign, and it's taking its turn. So the other car goes after somebody else, and then it moves forward, and then it waits for the car on the right to go, and then it's its turn, and then some pedestrians cross. They were looking in and laughing at us. They were like looking at, there's no one in that car except two people in the back. and it's like, it's a four-way stop and smoothly navigated all around the various corners that it needed to take. And I think it shows you on the screen the same thing as a real Tesla. A Tesla will show you like the pedestrians and other vehicles on the road. So here it stopped at a red light, so I stopped the video there and went into the exit sequence. So and then here's where it's empty. It's empty now.
It even waits for pedestrians.
Paul, did you find that it came up on the car at the stop ahead of it pretty quickly?
No, I didn't feel that it did.
It felt reasonable, huh?
Yeah. The whole ride was very smooth. It was just a really neat experience.
Did you feel it was conservative enough, or it looked a little aggressive occasionally there? It wasn't waiting for anybody.
No, I wouldn't say so, Ray. It didn't feel. In fact, it didn't feel tentative, but it didn't feel aggressive either.
Oh, okay.
It felt cautious to me. But cautious without being afraid to move when it was its turn to move.
Yeah,
it wasn't paranoid.
It just felt really precise.
Yeah.
So anyway, that was a neat experience.
Isn't Waymo one of the ones where they have like remote operators that can kind of shell into the car at need be?
Oh yeah, and so that was pretty interesting. When we were waiting for it to pull up, and it's sort of like Uber, it shows you where the car is or how many minutes till it arrives, and it said the car is arriving, and we had it. It showed the license plate, so we knew it was our car. And some people hopped out of the car. The previous riders hopped out. We just hopped right back in after them without closing the door. The door or anything, and so then we closed the door and pressed the lock button, and it wouldn't go. And so I pressed the button to call support, and it turns out that because it hadn't had its doors closed and locked them so that I could unlock them, it thought the previous riders were still in the car, and it hadn't finished their ride. So the support guy told us we had to get out and wait for it to end their ride, and before we could press and then it would notify me on the app that I could now unlock the car, and then we could get in. So I did that, and that all worked fine. And the operator was still on the line when we got back into the car for the second time, and he confirmed that everything was fine, and it was now our car, and then it locked the doors when we were in, and off it went.
Huh.
So no simple seat switches, huh, to tell you if your butt's in the seat or not, huh?
But did the car ask if you wanted to interact very much and talk with it? That's what I get on Uber.
No, it
an AI chat box.
It gave you a little talk at the beginning, at the beginning it like told you what to expect, and that it would look after you, and you could press the support button if you wanted help with anything, and then it just said enjoy the ride, and it started playing calming music.
Yeah.
You could have asked the car how to convert a C strut to Python.
Yeah. So anyway, that's all.
Yeah, John,
all I had.
that seems awfully restrictive. You can
Yeah,
only
this
have
is
one
fun.
global structure. I'm surprised by that. Me.
Who said that?
You said you can only have one global structure?
No, I didn't say that.
Oh, I thought you did.
Oh, God, no.
Okay.
No, you can have as many things as you want.
Okay, I thought that's what you said.
As many as you have memory for.
Thanks for the video, Paul.
Yeah, that was just such a neat experience, and I have to say a marked difference in quality of driving from the self-driving army trucks that I used to work on. It was pretty neat.
So what did a Waymo taxi ride cost versus was it
$14? So
oh.
it was, I was sort of thinking it's a little ironic. I don't know how many Google spent to develop this self-driving car so that I could go for a joyride for $14.
I can tell you my last 6-mile taxi ride in Toronto cost me $65 with a tip. So I can see where Waymo is a way better deal.
Hey.
So does Waymo compete with, Uber and other, well, okay, those are not self-driving.
Yeah, absolutely. Because, when we were going from the cable car museum down to the ferry, I just called Uber because I need to get down there quickly. But then on the boat, I pulled up the Waymo app and figured out how to work it and how to call for a Waymo. And, I just pulled the app up when we got back off the ferry. And so, yeah, it's absolutely a competitor.
Did you feel an urge to tip the car or the support person?
Did it ask for a tip?
Did it have its hand out?
Yeah, did it have it hand out for a tip?
You can unlock the doors when.
That's how you get out.
Well, that's a good point. You couldn't unlock the doors. I mean, literally, you were trapped in there, and they gave when the ride finished, it was sort of interesting. The voice the car instructed you that you had to open the door twice. The first time you pulled on the lever, it unlocked it, and then the second time it would actually open it. So if you didn't listen to its instructions, you might have been trapped in there thinking you couldn't get out.
So what do you do if you're a deaf rider? Huh?
What?
Well, somebody who's panicking is going to keep pulling the latch, so they'll get out.
Yeah, I guess so.
Bring a window glass break camera.
Interestingly, it was a Jaguar car. I'm not quite sure why they uses Jaguar, and
no expense was spared.
I did see them pair up with Jaguar like a few years back. There was an article on it. I forget the details, but
it probably has something to do with the renowned robustness of Jaguar electrics.
Oh yeah, they're real reliable.
Now they no longer use Lucas, the Prince of Darkness.
Okay, guys.
Do they do a how voice? I'm sorry. I can't open the door for you.
Sorry, Paul.
I'm sorry, Dave. I can't do that.
Sorry, Paul. Sorry.
Got to do it with a British accent, though.
Hey, hey, Harold.
Yes.
How's your video coming? Your video display screen coming along?
That it is coming along. You can see it right here. I am. It took me a little while longer to get home than I wanted to, and so I had to get me some dinner and feed all the dogs and cats. The missus is running around West Fort Worth taking care of a 6-year-old, something like that. Anyway, somebody much older than myself, and so I got most of it on the way there. And currently, what I am doing, I mean, I can show you a little bit of some of this. As I come around, it is a hair bit dark, and I can throw some light on it, but I've got my it's on right now, and I'm plugging in some stuff. I got a fuse link on the back side of this thing. I'm using these Wago style connectors here, so very little soldering on the back of all this. A lot of use of double-sided tape. I have a 30 amp 5-volt power supply here. I'm doing my power distribution through this. This has all got plastic or sitting on wood, so we're not doing this. I ran out a little bit of space because even though I modeled this up, I didn't fully model some of these things on the deal. I will tell you, these naughty starts, I have no idea who they are, but I found them on Amazon, and they've got a couple different styles of screw terminals for the ESP32s. And they even got a couple things where if you look at the edge there of it, you'll see these are a little thicker. So it'll take 2 different styles of ESP32. One's a little skinnier and one's a little wider in it. And it'll take all those. Also gives you pins and male and female header pin access right here. So you could do all that too, but then when you get ready to, so you get test points if you want. And then these screws go in, and it's actually kind of nice. If I get over the top, you can see that everything's labeled. So that's pinouts are there, and I've been just screwing them in. And so what I'm doing now is I have W lid loaded here. I've got one of the top bands, and then we go from in, out, and the last out we just don't go anything with. And what it looks like right now, because I still got to configure it, this is what it looks like. This is all 3D printed grids at 2 layers of white. So it's 0.4 millimeters of white, and the rest of it's a black grid. I got an example. Well, I had an example. I think I've trashed them now. Yeah, because I only printed I had to reprint a bunch of them, so I just reprinted what I needed. And I got one that goes 3 across. It's a 3x3 grid. And so eventually, when I get done tonight, I'll be able to light up all these. And then the W-LED stuff is really, really configurable. So you can tell it if you're going left or right. In fact, if I reversed one of these panels here, like these 2 could be the same direction. This could be reversed, depending on how you want to connect things up. Because keeping things short and all that kind of stuff, because you're sending, these are all basically what Adafruit called neopixels. So you can only shoot so much of that signal down the wire before it goes crazy, for propagation delay and that kind of stuff. And so this is configurable enough so that if I reverse this one panel, I can go into the web or the Bluetooth interface and say, this one zigzags this way, so does this one, but that one I've reversed it because I had to for some reason. And it knows internally how to set that up so it looks like one continuous line across it. If you start doing it, it knows how to do the mapping and stuff. It's pretty impressive. I say pretty impressive. It is impressive to me because it's work that I could figure out and I've done in the past that I don't want to do again, and somebody else has already done it. So I'm more than overwhelmed with the greatness of that. And there's a couple of things that happened on this. I grabbed the big bad light. So panels are 16 by 16. And you've seen them before. I think I've showed them a couple times, but they're just a big grid of WLEDs. And I mean, not WLEDs, just LEDs, the WS2812, 28 something other, that in that range. You can tell
2812.
2812, yeah. You can tell I can keep up with the all the numbers and stuff. So this is a piece of this back part here is a piece of MDF that I did the Fusion 360 drawing of this whole thing, and I've got drawings, so we've got cut patterns and all that kind of thing. I've still got to update some of the parts list, the bill of materials on the GitHub for some of these things I did, and so I was able to cut this out, including all the holes, painted it up, and then I stuck those panels on front. Here, you can tell here how big a panel is. I stuck them on front with tape, the double-sided tape, and then I put these panels on top. And I was wondering how I was going to secure them, because I don't want to stick all this to the panel itself, because I might have to change out a panel or something, right? But if I do, I'm not going to be happy about it, because it's a kind of a pain. But I wanted these to be removable. And lo and behold, all my 3D printer stuff had laying around with this T-track. If you'll look real close, if I can get it, you see that screw right there? That screw takes a T-nut, and the button head is big enough, just big enough, so if I screw it in there tight where it won't move, it's big enough to hold the panels in. Like it was almost like I designed it that way. And I was happy to see that. So I make sure you see it there. And I'm like, is that going to work? Is that going to work? And I got a couple other things if it didn't work. And it just worked. And I'm like, I'm so happy with that. So that'll be there. So I intend to have this thing up and going. And there's a little bit of a robot-y thing that the WLED mascot. It's got an LED with headphones and things that dance up and down. At the very least, we're going to have that going. And then I'm going to see if I can't do some other thing going on at work. But this is art month, so just do some art. So this is what I'm going to enter in for the art contest, and I'm probably going to figure out how to do some 48 by 48 pixel art. And as Paul suggested, we'll see if we can get Robbie in here somehow doing something. No promising. I mean, I draw stick figures. That's what I do. So I don't know that I can actually do really art. But anyway, that's what we're going on this. And that's my current project. And I will tell you another thing, just like on HugoBot, this screw terminal thing is like a godsend, especially for the things we do and the stuff we put together. It makes it so easy. I say so easy. It's a good secure connection. You can throw this thing around. And the way this is all bundled up and put together, I plan on hanging this on a wall at some part from the very back of this. But if I want to set it on the desk, hang on a wall, and the other thing here is I got enough parts. I got enough LEDs to make a 32 by 32 version of this. I just don't have enough of the extrusions left over, and we'll put those into the purchasing queue to get all those kind of things. Since I got a cut list, it made it real simple to go set up and cut all the things the way they were supposed to be, measured them really well, and then when I started putting these things together, things actually fit that I measured and that I actually planned out and cut to the length that it said Fusion told me to cut them to. And that was pretty impressive, actually.
Wow.
Yeah.
Neat.
So Harold,
anyway,
what was it for? Was there a contest that you entered, or?
No, not at all. What this was for, truly, is because I saw it on YouTube, came across my feed, and thought it was neat.
Okay.
So I'm like, let's do it. And then after I decided to do it, I mean, this was months ago. I decided to do this. It took a while to find all the pieces and parts and get past the Robo-Rama and other things to bring it up to the queue and put it together. I will tell you, I'm not proud about this. I had to figure out some stuff. Let me put this back on here just for a second. I was doing a thing. I'm like, man, this is going to be so cool. It's maybe hard to see. Let's see. You'll notice that this bolt here is a little bigger than the other ones. It's because when I was doing my research, I found out at the end of these 2020s and 2040s, that hole they drill in there is supposed to be tappable, a 5 mil, ready to be tapped with a 5 mil end. And so that's what I did with this one. And this one down here that doesn't have a nut on it now. I'll explain that in a second. And it worked really good with 5 mils. But then I came over to here and the holes were too big. So I had to up to 6 mil to make it work. And so I found me a drill and tap that would do the right hole. And it was one of those combination drill and taps where the first little bit of it is a drill part, and then it starts tapping, right?
Yeah.
I got it. I drilled this one, the one down here. I mean, this is going great. This is awesome. Then I got over here and drilled that one. Okay, let me make sure it's in I drilled that one. And guess what happened? If you look real close,
It broke through.
if you look real close, you may see the end of something in there that's not supposed to be there.
Broke your tap.
There's
That's a locating pin, right?
Oh yeah, that's exactly what it is, Carl. Thanks for the spin. But
They are so easy to shatter.
and I will tell you now, if you have never done this, and I knew this going in, by the way, I was trying to be careful. I got a little excited because things were working good, and that's what I got a little overexcited, and I wasn't watching what I was doing as close as I should have. Because I was going a little faster. If I'd have just slowed down and pulsed the thing as I was going in, this probably never would have happened. But I was going on. I said I can do this in one shot. Dang it!
Hey,
there's lots more.
Hey, Harold.
Yeah.
Do you use tap fluid when you do that?
Yes, I had some cutting fluid. In fact, that's still sitting around here. That's what I was using.
Yeah, those things are so brittle that a little too much torque and snap.
A little bit in the wrong way at the wrong time, right? And it snapped it. And I tried to get it out, but it was wedged in there so hard I couldn't get a good grasp on it. And because that's hardened steel, I'm like, there's no way I'm drilling this out. Screw it. I'm just going to shoot that with some black spray paint and we'll call it good. Because with all these with all of this going on right here, there is no way that corner is coming out. I was actually doing this more for aesthetics than anything anyway, with that corner thing, and to cover up the end of that. And I'm like, okay, I'm just going to shoot it with black. You could put it in the back corner, nobody will see.
You could always cut off the end of one of those screws and just glue it in place.
That's a great idea. I might do that.
That is a great idea.
Hey, if it works, you know. What is it? What's the military thing on that? You beat it to fit and paint it to match. Isn't that how that works?
Yeah. File to fit, paint to match.
Yeah.
File to fit.
File to fit and paint it to match. There you go. And but it's things you learn, and I don't mind showing everybody that because people learn from my mistakes, and hopefully they don't make as many as I have, and we get going on it. It's kind of how the whole thing works. And so
we had to design our own diffuser to turn the round LEDs into like squares like that. Did you say you had to do the same, or did you find a diffuser that's nice?
I would have, but there was the person on the video. I need to find that video. I got it on my list still, I think, or maybe I removed it because I was done with it. I got online, and there's a couple people out there make these videos and made a couple of grids, and I just so happened to pick one up that fit the 16 by 16 because these are fortunately for me, all these grids are pretty much a consistent size. If they're 16 by 16, they're going to be 160 mils on a side, and day in and day out. And somebody else
for making centimeter square per pixel.
Yep.
We've got 16 by 32 panels, and there weren't any ready to purchased diffusers when we were doing
Yeah.
it. So if there are some now,
Yeah, I
I
had
can be pointed at them.
Yeah, I got somebody had an STL up there. I grabbed the STL, I looked at it, did a test print. Ooh, that fits. Let's print 8 more of them. You know.
Oh, you did have to print it still. Okay. I was looking for like an off the shelf, hopefully.
Oh, I didn't. I know I didn't find it off the shelf at all. I didn't even go look. I didn't even go look, just because, you know, I'm kind of a 3D printer guy at work and all that kind of stuff, and
sure,
the things I do, and I'm not opposed to like the styrofoam ball that Mike got. I mean, can I 3D print that? Well, maybe, but why would I want to do all that when I can get a ball for a few dollars and save me a bunch of headache? You know, I'd rather have stuff that works than stuff that doesn't. And this was and I knew, because I had to go through a couple of these models on the thing because of, I don't know, some weird sizing. I wanted to make sure they fit, and I didn't know if it was, if you follow me on Facebook, you'll see where I tried my first set of diffusers, and they were literally off by 2.5 millimeters. And these things are nice and sturdy, so you're not just going to squeeze them in there to fit. Okay, unless you break them, and then that's going to not be the right thing to do. And so when I pulled in that model, I got to looking at it, and yep, it was 160.4 millimeters. Now, why it's 0.4, I don't know what the fella did. I can't imagine, but it was. And so I used my my slicer to reduce the size by 0.4 millimeters on each side, and each, you know, X and Y, and then okay, let's print that one. Dude, that fits. That's just right on there. Just right on. And no, but in all this other stuff, I'm not sure how I was going to do the wiring and things back here. So I kind of knew what I was wanting to do. Like, there's some double sticky tape that already came off already. Slacker. But I probably need to do a better job than that. But with all the Wagyu style things, even if it'll still be all right, nothing's going to short, nothing's going to go crazy. About the worst thing that's probably going to happen is if they all come off and I'm dragging these things around, it may detach themselves from the soldered points to the panels on the back, because theirs are just soldered on there with a good blob solder. You know, it's definitely a point of stress, but nothing's really pulling on them hard, so got plenty of floppiness going on. I got to dress my cables a bit better though.
So you're going to have it at Frontiers of Flight?
Cool.
That is my plan, and we'll have it doing all kinds of stuff. It knows how to talk to Wi-Fi, knows how to talk to Bluetooth. There's an app on your phone that can drive it, or you can just hit, once it comes up, if it has an access point you can just hit the web access point on it. Up comes a web page that allows you to control the whole thing with all the stuff. Got to learn some pixel art now too. I'm not sure how all that's going to go. That's probably going to take longer than I want it to take.
Cool.
Yeah, but there's.
Cool. Thanks for the update, Harold. That's pretty neat.
You're welcome, Paul. I mean, this is not really a robot or nothing, but it is way fun. At least I think so anyway.
I've got a small update I can show.
Good. Yeah.
Nice.
So last week I had showed my drawing for my big outdoor bot. I was waiting on some parts to come in, and a few things arrived today. And basically I started laying everything out in the bottom. My bevel gears showed up. So I've got all my bearings. I've got everything I need for the inside, I believe. I'm waiting on some bushings for the shafts for the wheels. So that's one side roughly laid out. Everything's got to shift in the picture upwards to about 5 or 6 inches to stick out the side of the robot to mount the wheels. And that'll be mirrored on the bottom side for the, one side for the left side, one side for the right side. So shaft drive robot for outside. So that's about it. Just slowly getting everything in and start putting it together.
Very cool. How do you keep the shafts from sliding on the bearings?
I have shaft collars. So the bearings have set screws, but I have some much bigger shaft collars. So they'll do a much better job of gripping the shafts and keeping everything from sliding over. I've got a set of thrust washers to go between the bevel gear and the side of the box, so that I'm not wearing away on the plywood. And I've got, on the outside, I'll be putting some flange bearings to support the shaft from the outside of the robot.
For those of you interested, I put in the chat a YouTube link to the thing that sort of inspired me. Not that I did a whole bunch different than him, but I did make a case for it and that kind of stuff. But if you want to see what got me inspired on the things there. Sorry, I talked you over you, Pat. I'm sorry.
That's all right. I was done anyway. That's all I had for an update.
Hey, so Pat, how are you going to finish that nice? Are you going to go with the natural plywood look? Or are you going to trick it up into?
I thought about fiberglass.
Fiberglass?
Yeah, I was thinking fiberglass possibly, but I'm not sure. It was just some old plywood I had lying around. So the bottom is 3/4 inch. The rest of it is 3/8.
You know, we had Doug do steampunk. Maybe you could start a new genre called woodpunk.
There you go.
I was going to say, you got some leftover steampunk paint, Carl, or you want to?
There's always that. But I like the new genre thing. I think Pat could do an awesome job of woodpunk. It would fit, right? Get a few sawmill gear, saws on the outside. You know,
easy enough to do. I got a whole garage full of saw blades and stuff. So
yeah, there was a thing called the Wacky Races, Hanna-Barbera kind of cartoon thing back and they had and one of the thing was the lumberjack thing, and they had like saw blades for wheels and all that stuff. It was awesome. You gave me fired a neuron there. Fired a neuron.
Totally forgot about that.
So Kareem, you know what I'm talking about?
I know what you're talking about. Yeah, it's shameful, but I know.
that would turn Robo Columbus into a sport.
I remember that cartoon too.
Yeah, Dirk Dastardly and Muttley, and you know, the really bad evil guy had the fastest, most fantastic car, would get like miles ahead of everybody else, and then start cheating to make sure he won, and so he never won at all. So that kind of thing, kind of funny on that deal.
Yep.
And Professor Pat Pending and his converter car.
Now that's inspiration, isn't it? Right there.
Yeah.
Although looking back, you want to know, know what their inspiration was, but that's some kind of chemistry.
I added an LED voltmeter to the back of my thing, and it basically is just a little 2-wire display that you plug into a voltage source. And in this case, what I did is I soldered a JST balance plug onto the end of that wire, and it plugs into the balance connector on the battery, and I can see the voltage of the motor battery that way when it's driving, which is handy.
Nice idea.
And you can get those reasonably cheap for, you can get like 4 or 5 of them for $10 on Amazon.
And 3 times as many at Ollie or Banggood.
Yeah.
I like that.
You get versions that will
idea.
show
I'm
you
gonna steal
current
that.
draw as well.
Sorry, did somebody ask something?
I thought Paul said something as well.
No, I just said I might steal that idea.
The versions that do current draw show you your amperage as well, or really high.
Yeah, but you couldn't do that by going through the balance connector. I think the nifty thing about this idea is going through the balance connector to get the voltage.
Yeah, because you don't normally use the balance connector on those batteries on, you know, so it's pretty simple and it works nicely.
You know, I hadn't thought about doing that. That's pretty cool. It's a good idea.
Yeah, I had it on when this was an RC rock crawler, because of course there's no telemetry back on that. So I just stuck it in the back window of the vehicle so that I could see it when I'm walking behind it.
I just like the always on display. And the set I found at, I think it was Banggood, not Ollie, but they had 3 or 4 different colors available. So you could choose the scheme that you want to match your wood punk or cyberpunk, whichever way you're going.
Yeah, this is just one I happen to have sitting here, but I bought a 5-pack and they're all different colors, and I've used them on various projects for mostly RC cars for that sort of thing. So,
although I found it was weird, it seemed to me that the green was much more dim than the other colors.
Yeah, I think blue is probably the best of the colors.
Yeah.
Well, guys, is there any other questions or presentations?
Y'all have a good night.
That's where we are. Everyone else, take care now.
Good night.
Good night, guys.
See ya.
Thanks for hosting the meeting, Pat. I appreciate it.
No problem.
And Carl.
Yeah, no, it's Pat. Pat ran it, and we're gonna lean on Pat next week because I'm out. So take care, guys.
That was nice of Carl.
All right, I feel bad. I want to help.
Safe travels up to Michigan, Carl. I hope you have a successful trip up there.
Pennsylvania, but yeah, the other Michigan.
Oh,
So,
Pennsylvania. Sorry, yeah.
it's okay. My daughter from Illinois. Almost. Anyhow, take care, guys. Safe travel. Safe travels.